Hi guys! So today I'm going to be doing the Conservation of Matter lab. That lab requires a empty bottle, small bottle, no lid. It needs a balloon, some baking soda, any kind of vinegar will do, measuring cup for the vinegar, measuring spoon for the baking soda, and I have some supplies that are going to help me pour, and you're just going to have to do your best at home. I also am going to use a triple beam balance because I'm going to find the mass of our bottle container with the balloon and everything in it before and after we do our reaction. So I'm going to share my screen and make sure that you guys all have this part of today's module, module 22, open to Conservation of Matter lab. We have a brief introduction here. Make sure that you have clicked on the link and made a copy of the document and did the first couple of parts together, the hypothesis and the variables. All right, so I'm going to start doing the experiment from the procedure. We'll go through all 5 steps, including measuring the mass. So I'm going to stop sharing so you can see what I'm doing. All right, so step 1 is to measure 1/4 cup of vinegar and put it into the empty bottle. So here's my 1/4 cup. And this is really hard to pour. As you can see, I already spilled some, so I'm just gonna put it into something with the spout so that I don't make an even bigger mess. Okay, there is my vinegar. My next step is to measure 1 tablespoon of baking soda and put it into the balloon. So this can be tricky. Okay, that's a tablespoon. Now I decided it would be easier if I put it into a paper cup and then pinch it so that it can actually pour and get into the balloon. Some is probably still gonna miss. Okay, so I have most of the baking soda is in there. So my next step is I'm gonna stretch the opening of the balloon over the opening of the bottle. And I'm gonna make sure that it's on there good, so it's not gonna let any gas escape. Now at this point is where I'm gonna just do this extra step because I have this scale, and we're gonna find out how much mass does this closed container system have before we mix the 2 chemicals and then after. So here we go. Less than 200. Okay, less than 110. Okay. So it looks like I have 100 and a little bit too low. 104.4. 104.4. So remember that number. Now, the fun part. So I'm going to wrap my hand around this to try and keep any gas from escaping. And then flip the balloon. Give it a shake. Help speed up that reaction. And then wait for the fizzing to stop. Okay, so we got a nice fizz and we got some gas we collected in this balloon. The balloon inflated. Now let's see, do I have the same amount of mass as when I started? Okay, so it looks like it has gone down just a little bit. Maybe about 1 gram. Wow. So now we have 103.4. So we lost exactly 1 gram of mass. What happened to it? Well, this isn't a perfect closed system. There is tiny, tiny little cracks that let some gas escape between the balloon and the bottle. And so we can imagine that 1 gram of gas that was produced from this reaction escaped through the opening of the balloon, but all the rest of the matter stayed inside the container. Even though we got a balloon full of gas, this did not make the whole thing any heavier because it didn't add any mass to what was already there. We simply rearranged the order of the chemicals that were in here. We rearranged the molecules. Okay, I don't think I can get this off, but if you can get yours off, it's fun to tie this balloon that's full of carbon dioxide gas and see how heavy it is compared to the air around you. You'll notice it sinks pretty quickly to the ground. Okay, that's it for this experiment.